Okay, so this is the last slide of the talk. In each of the examples in this talk, all of our minds have automatically and spontaneously generated storylines. And we've all pretty much generated all the same storylines. Now, there's going to be individual differences, but all of us pretty much have solved the frame problem in the same way. Now, if computers are going to interact with us in a natural way, if they're going to understand our natural language, the computers will have to learn how to read between the lines and learn how to do it in the same way that human beings do it. And to do that, you have to recreate the same information processing systems that the mind's using to keep the computer in frame. And furthermore, from the point of view of creating strong AI, I believe that you have to re-implement what Descartes is talking about in the computer programming in a way that makes sense for a computer program, to create a computer programming structure which exists on the edge of complexity. Okay. Are there any questions?
Thank you very much, does anyone have any questions?
Yeah, I have a question.
Sure.
So qualia, is that almost the same as subjective experience?
Yes, that's it. Yeah.
Okay, for instance, it could be that two people have opposite subjective experience for color, like blue and green, say. It could be just flipped around between two people and you would not really know from the external behavior.
That's right.
Now, your notion of qualia in your flow diagrams is maybe not exactly the same of subjective experience because it plays a functional role in the diagram.
Yeah, well, that's right. I subscribe to the idea that qualia plays a functional role in the information processing pipeline of the brain. That's right. So if I perceive red as green and you perceive green as red, no, if I perceive red as green and you perceive red as red, then that is going to affect the qualia that's produced in our respective minds. But that qualia is still going to be presented to each of us mutually as a real, smoothed over reality, simplified reality, which the executive can make powerful inferences from and create beliefs about itself from. Okay. Thanks.
Where did we get to
the
the lovers?
Google.
Found it on the internet.
I found it on the internet, yeah. Okay, what else?
No questions. You covered.
I covered everything.
I can't believe that. I don't know how we're going to work this into our project.
Oh.
But it sounds like it should be. We should try to do it.
Well, okay. So people have been trying to work with this stuff directly from a computer programming point of view, and obviously there's lots of challenges there. So there has been a research effort to model Lentami's causation, and the idea is if you can get Lentami's causation into a computer program, if the computer program can make those powerful causal inferences about a scene, then you can improve machine learning. When it comes to evolution, like, I know a long time ago, I think that there was this research effort where they thought they'd evolve algorithms by producing machine code and then selecting for the machine code which solved the problem better. And it didn't really go, it wasn't successful. And I think that was back in the 70s, I think. The human organism is nonlinear and it's on the edge of complexity. I think it's really important that you get something which is right there between order and chaos, or you get something which is going to have that feedback, you know. And then when you apply evolutionary pressures to it, then you might start seeing emergent behaviors. Now that's just a personal belief. I haven't tried it out. I'd love to though, one day.
Yeah, it would be really good. But this causation idea is, you only got binary relations. You've got 3 binary.
Yeah, you got 2 by 2 by 2 array. So there's
so what about? We don't tend to think in utility. Well, we do have utility relations. I can't think of them off the top of my head now.
Oh, okay. Okay, so this is something you can find in broader cognitive semantics. So Lentami actually looks at all the different verbs in English and Japanese and a few different languages, and the different causal constructs. And the examples that I gave, like the street cat set the house alarm off, they're sort of like complete examples, but languages usually have simplifications where the causal constructs are condensed. So it's like, you know, Bob broke the lamp, or you could just say the lamp broke or something like that. And if you look into Len Talmy's work, you can actually see how they go from those basic linguistic structures to these binary propositions, which are always there. But the brain does work, like we have an innate ability for rationality. It's just part of the human system. And so we're all naturally able to create propositions and see whether they're logical, whether they're rational or irrational. All right?
I wish you'd tell my first week of speech touches people about
So, Aaron,
Yeah.
I'll do one question further.
Yeah.
Let's just say that in a meditative technique where you reduce down the linguistic activity to zero, so you're just sitting without any.
Okay, that's impossible.
So there's no possibility of sitting and in the open space. I'm just
Well,
wondering what happens to the
The qualia?
qualia, and then